Okay, so I wanted to give you a rundown on where we're up to. So Layla has sent me a massive amount of information about all the samples and all the bugs and all of the media and the way that the bugs look, the way they behave. And so there's a lot of stuff to organize even before we get on to the actual MALDI bit. So here is a typical sample, the wound swab uh, from week 6, and there are 6 possible types of bacteria in this. Now, I've made it so that you've got the flexibility to add even more. So these are all the bacteria that are in on the book, so to speak. So these appear each of these appears somewhere in weeks 6 to 12. But of course, it means that they can be added to any sample. So you can generate completely novel samples if you want. Um, the samples obviously are grown on particular media, and again, very wide range of media available. And for each of these bugs, there's stuff that we know about it. So we can zoom in on a particular bug. This one, the Staph epidermidis. We know how it behaves on catalase. Layla's going to tell me how it behaves on oxidase. It may not be an assay that they do in week 6, but it opens the door to having it as an assay that students can do. Now, crucially, how it's going to appear down the microscope slide. So when the student has sampled from a colony and it's got this bug in it, it should appear like this. Now, Layla's given me some samples of pictures for how things behave on a gram-positive test, and I'm going to get work with my graphic designer to make it so that these are made in a sort of agile, random way, so that it won't always look exactly like this picture when it's gram-positive. Um, Now, this staph epidermidis might grow or not grow on particular media. So we can record how it behaves on particular media, and we can even go further than that and talk about what it actually looks like on particular media. So we can start crafting some notes about how tiny this is going to be, how much smaller than other bugs it's going to be in terms of the uh, the, the colonies that are produced. So if we were to look at all of the bugs, so like we know how this one looks, we know how this one looks. We just need to compile how it behaves on different media, and of course whether it's sensitive to particular antibiotics. So this is quite a complicated database, and it actually brings together loads of information about each bug, what will grow on each particular plate, what type of media is used in the processing of each sample, whether antibiotics are present, how the gram stains look. All sorts of things are brought together and interrelated so that basically you have incredible freedom to design completely novel samples, which is a fantastic bonus, but it's also the platform on which the Unity piece is driven as well. So the Unity piece understands what it needs to do on any particular sample from that database. So where are we with the Unity? Well, if I'll just play this maximized. So what we've got here is a little splash page, and we'll go to the MALDI. And when we open up the MALDI, then what we'll see is a bench that looks a bit similar to the one for the micro one that we did last year. Um, Basically got an oven, a picker, and an area for the antibiotic discs. Um, but the main thrust of it is that you can generate samples, and the database makes it possible for these samples to be generated outside of Unity. So the dream here is that you can say, well, I want a sample that will contain the following three bugs, and it will the system will know that sample number 12 is that. So let's generate a plate with sample number 2 and some BA media. So we get this plate which has been streaked with the BA media. You can't see much on there at the moment because it hasn't been put in the oven, so none of the bugs have actually grown. If we pop it into the oven, then it's incubating away, and you can see that we've got three different atmospheres that we can incubate in, the O2, the CO2, or the completely anaerobic. So when we pull that plate out, there will be some growth of the colonies, and these colonies can be picked and they can be placed onto a slide. Now this slide here is where we'll put the colonies, and then by clicking these buttons here, we'll be able to get a visual picture on this screen of how that test has worked out for what's been picked. Sometimes, of course, it might be a bit ambiguous because there might be uh, some reason why there could be two colonies growing very close to each other, and that's what the picker has picked. But for most of the time, this will really help in the preliminary identification of the bacteria. So this is all very nice. We've got this, and again, all of the picture of the gram stain and the picture of the oxidase and the catalase stain will be driven by the database. How these colonies here look on the plate, how the plate looks, the color of the media, how the color of the media changes with the incubation, the shape of the colonies, the color of the colonies, the size of the colonies, all of that driven by the database. So and totally under the control of the course coordinator. So then the other thing, of course, that we did before was we came up with a way of making it so that we've got the let's play this. This is the MALDI. Now the idea here is that we would have picked we'd have picked the colonies, put them onto the MALDI plate, which is a bit unsophisticated at the moment, and then generate a report. And that report will have the particular bugs listed as likely candidates given the database hits that the MALDI has produced, and later has provided me with some nice cues for what these database hits could be, whether or not the assignment is strong or weak or whatever. So that's already looking really good. The extra information Layla's provided is excellent, and basically it's now just a question of pulling everything together. So we've made some really good progress. That's where we're up to, and yeah, we'll keep